Hi everybody, welcome to test 1 review in linear algebra. Um, you will see that there's a list over there. We'll go through as we go along. I will check off that list so you can easily follow what we are doing. Right, let's start it. The first one, we have to be able to recognize the echelon form and the reduced row echelon form. For that, we go to question 4 to 6. I will update the list of the questions as we go along. So for the echelon form or row echelon form, we need to be able to locate the pivot entry. So on the first one here, we see that this is a pivot. Then we go on the second row. The first non-zero is going to be here, and the first non-zero entry is here. They align on the steps or the echelon form, and above that is not zero. So this is only in the echelon form. If those numbers happen to be zero and those are ones, it will be reduced row echelon form, so which is right. This is going to be just echelon form. Right. Next one. I will look on the first non-zero entry on each row. We'll just do that. And this is not in the echelon form, so we'll just say it's going to be neither. So we will locate the first non-zero entry on each row. If it is on the steps, it is in echelon form, and if we just have 1 and 0s, wherever we have the pivot entry, that will be reduced row echelon form or just reduced echelon form. So again, the first non-zero entry, this happened to be 1. It is in the echelon form, which is good. And on a pivot column, we only have 1 and 0. So this is going to be reduced echelon form. If we just have 1 and 0 on the pivot column, then it will be reduced echelon form. If we have a row of 0, it must be at the bottom. So that will be the first topic. As you see, I just go and check off the list as we go along. I will put the number of questions on the test review so you can see where it comes from as well. Right. Next, we go to system of equation. For this, we might have just something like the system of equation, or it might be a work problem. So let's look at the first one. And for this kind of problem, we just use the calculator. So first, for this, all we need to show is we write that in the augmented matrix. This will be -8, right? And we just put in the augmented matrix and use the reduced row echelon form. Right. So it will be second matrix. Go to the second tab, and there will be math, where it says RREF, and I will just put the matrix. I will hit alpha and then zoom. Sorry, forgot the alpha. Alpha, zoom. This is the 3 row 4 column matrix. Now we just enter the numbers. Do not hit enter here. Just hit 1 and then go to the next entry. It will be just like that. And we have 1 0 0 0 0 1 0 8 0 0 1 0. So on this we have pivot entry, and so all of that are basic variable. So we have x1 is 0, x2 is 8, and x3 is 0. So we say x1 is 8, 0, x2 is 8, x3 is 0. So that's pretty much it. Right. So we did number 1, and of course different form of equation. I'll go to this one will be similar to that. The work problem, we just read the problem and then try the equation, and then we can do the same thing. Right. 7 and 8 kind of the same thing as well. So we will write this as the matrix 5 2 1 negative 11 2 negative 3 negative 1 17 0 7 wait, the 7 is actually is for the x, so be careful with that. The 7 here is actually is for the x, and negative 1 is for y, and there's 0 for z. Right, so 7x negative y and equal to 12. Yeah, so be careful with that. And then we do the reduced row echelon form. Right. So second matrix, reduced row echelon form, 5 2, oops, need the matrix. Still 3 row 4 columns. Right. 5 2 1 negative 11. I just put the numbers in. Wait a minute. Just hit enter here, and we have that. We can always change this to our fraction. Hit math, change to fraction, to hit enter, and then enter again. So we have that. So we don't need to copy the whole matrix. We see that on the last row, 0, 0, 0, and 1. This is where we have no solution. So when we have a row of 0 and something else, that's going to be no solution. Right. We're going to do 8 also. So for 8, put that in the matrix form. 1, 1, 1, 7. 1, negative 1, 2, 7, 2x, 0y, 3z, 14. Right. So again, go to reduce row echelon form. And we have a matrix also 3 by 4. Alpha, zoom. Right. Let's see if I can enter 1. Oh yes, 1, 1, 7, 1. Again, if we use negative, it has to be this negative sign and not that subtract. So negative 1, 2, 7, 2, 0, 3, and 14. Right. And we have that. Right. Let's just gonna. We can also change to fraction, or we can just leave it like that. But I'll change to fraction. So hit math, and then enter twice. 1, 2. So we have that. Now we see it, there's a row of 0. That usually doesn't tell much, but we look at the pivot entry at the 1, and if we put the x1, x2, x3 for the corresponding columns, we see that x1 is basic, x2 is basics, x3 is 3. So we start with that first because x3 column doesn't have a pivot entry. So we say x3 is 3. And from these two equations, we will have x1 plus 3 half x3 equal to 7. And so we just minus that on the other side. We have x1 equal to 7 minus 3 half x3. See if we have different. How I do. And then for this one we have x2 minus 1 half x3 equal to 0. So move the 1 half x3 on the other side. We have x2 equal to 1 half x3, and then the x3 is, of course, is 3. And that is the solution for that problem. Now we update the list. So pretty much that's the system of equation. We just use the RREF, and on the test we just need to write RREF like we did here. Again, doesn't matter what happened for the rest of the matrix. When we see this, there will be no solution. When we have the row of 0, that doesn't tell much. We still need to find it, and that infinitely many solutions in this case because it has a free variable. Right. Next we go to use the row operation. I need to load the program on. Yeah, it doesn't have it. I cannot load that onto the calculator here, so we have to do that the old-fashioned way. Right. So we have this. Next problem will be. Wait a minute. Right. I just go over this quickly. On this matrix already in the reduced row echelon form, so we can say that in this one, when we have a row of 0 and there's something else, that one is no solution regardless of what happened the rest of the problem. On this one we have a pivot here, a pivot here, and let's say a variable, and x3 is free, so we start from there and we write the rest of the problem. I'm not gonna do that. Right. Next we go to the row operation. Right. We need to do on the step. I'm going to use the calculator, but I have to do that like this. Need to zoom out. Just a second. I'll just do this. I think that's better. So on your calculator we should have the program that called the row ops. First we need to store the matrix into the calculator, so I hit second x to negative 1 and we store that. Let's say put that in the matrix A, 3 rows, 4 columns, 1, 4, negative 2, 3, negative 3, negative 11, 9, negative 5, negative 2, 3, 4, negative 3. Right. We just hit every time we need to quick that second quick. Second matrix, the matrix A, I just hit enter, just checking to make sure the values are the same. 1, 4, negative 2, 3, negative 3, negative 11, 9, negative 5, negative 2, 3, 4, negative 3. Alright, that's good. So we store the matrix into the matrix A. So put edit and then put that in the matrix A. Right, next we'll do the row ops. The first, the row ops, hit enter, select the matrix, we choose matrix A, so hit enter. Right, enter to continue. Right, now let's see what we need. In the row echelon form, the first one we need is this to be non-zero, and that will be the pivot. So everything will spin off this and we turn those two to 0. So I will write this column, turn that to 0, turn that to 0. Right. I think I can zoom back in. just need the calculator screen pretty much. Right. So this one is the row, on row 1 is the pivot, so we'll base off the pivot, always that. Now we're going to eliminate the negative 3 to 0. Every time we eliminate, we use the opposite of negative 3 is 3. And we're going to add to the row that we eliminate. That will be row 2. Replace to row 2. And this opposite, add to row 3, replace to row 3. Alright. So that is a multiply to a row and then add. Use option number 4. Right, multiply row 1 by 3 and then add to row 2. Right, that's good. I don't need to copy that down yet. Just keep going with this. Enter to continue. Option number 4. Multiply row 1 by 2, add to row 3, and that is that. Let's copy that matrix for now. 1, 4, negative 2, 3, 0, 1, 3, 4. Right. 1, 4, negative 2, 3, 0, 1, 3, 4, 0, 11, 0, 3. Right. Now let's check. We have the pivot here, which is good. Everything else 0, good. In the next column, we see that the pivot is going to be on the second row now. The first non-zero entry is here, so which is good. So that one is good. All we need to do is turn this to 0. So this 11 should be 0. Now the pivot is on the second row, so everything will spin around row 2. And since we want to eliminate this, we use the opposite of that number. Add and replace to the row we try to eliminate. So that's pretty much that. So hit enter to continue. Choose option number 4. Just hit 4 actually. So multiply row 2 by negative 11 and then add to row 3. Again, if we use the negative, use this. Don't use the subtract button. I think we make a mistake. Don't worry. If we make a mistake like this, just second mode to quit the program. Now we go back to the matrix, to the program. Instead of use matrix A, I use matrix E. That's the last correct matrix. It should be this one. As you see, we have that one. So we're still good. We continue from here. Option number 4. I just hit number 4. Right. So multiply row 2 by negative 11. Have to hit enter there. Add to row 3. Right. And that's what we have. Notice that in this problem we have on the first non-zero entry is the pivot entry on the steps. So this is in the echelon form, and pretty much we're done with this problem. Right. That's question 11. Now we'll go to 12. This is echelon form or row echelon form. Right. Next we'll go to reduce row echelon form. There will be a lot more work to that. So since we're done here, then hit second and mode. Second mode. I will have to hit enter to continue. Alright. 7 to quick, so just hit number 7. Number 7 again. Okay, we good. Alright. Now we're going to put this in the matrix A, because I usually just need to put that in A. Alright. 3 rows, 4 columns. 2, 1, 1, 10, 1, 0, 1, 2, 3, 2, 2, 17. Right. Second mode to quick, and then second matrix. Usually I just check to make sure that the numbers are correct. Right, all good. Now program, row ups, enter, apply to matrix A, hit enter to continue. Right, on here, if it is in the echelon form, we really don't care if that number is 1 or anything else other than 0. But this is the reduced row echelon form. Different here is it is reduced. So this has to be 1. So to do that, we just need to swap these 2 rows. So we'll do that. So we will have, actually we just do it on the calculator too. Row swap, the first option, hit enter. First row is 1, second row is 2, and we swap these 2 rows. There. I just copy from the screen. 1, 0, 1, 2, 2, 1, 1, 10, 3, 2, 2, 17. Right. Now we have the pivot entries at the 1 here, which is good. We'll turn the 2 to 0, the 3 to 0. Right. Since the pivot is row 1, I will spin around row 1. Right. Opposite of this number to eliminate, -2, add, replace to row 2. Opposite. Usually for this we just do 2 at the same time, 2 at a time, when it's like this. Right. So hit enter to continue. I'll do that. I choose option number 4. Multiply row 1 by -2, add to row 2. Right, so that eliminates. Good. Enter to continue. Option number 4. Row 1 by -3 and add to row 3. So that's good. I'm going to copy from the screen. 1, 0, 1, 2, 0, 1, -1, 6, 0, 2, -1, 11. Right. Let's check. The 1 here, the pivot, which is good, 0, 0, good. The 1 here is the pivot on the echelon form, so that's 1 is good. This 0 is also good. We just need to turn this to 0. In reduced echelon form, everything else in the pivot row has to be 0, except for the pivot entry, of course. So we're going to turn that to 0. And the pivot is on row 2, so we use row 2. Use opposite of a number to eliminate. Add and replace to row 3. So enter to continue. That will be option number 4. Multiply row 2 by -2, add to row 3 and replace to row 3, and we have that. I'm going to copy that. 1, 0, 1, 2, 0, 1, -1, 6, 0, 0, 1, negative 1. Right, now let's check. We have 1 here, which is good, 0, 0, that's good. Pivot here, good, 0, 0, that's good. Next row, the first non-zero entry is 1, so that is good also. All we need to do is turn those two to zeros. Those two numbers to 0. Alright. Now the pivot is on row 3, so we use row 3 twice. One for this one, one for that one. Opposite number to eliminate, so negative 1. Add and replace to row 1. Opposite to that is 1. Add and replace to row 2. I think after this we are done actually. Sorry, I hope you see the screen. That right, this one. Enter to continue. I choose option number 4. Multiply row 3 by negative 1. Add to row 1. And then multiply, hit enter to continue. Option number 4. Multiply row 3 by 1. Add to row 2. And we have that. Actually, that is the end result. So I'm going to put that somewhere. Right. Yeah. We should have that. So that's what we have, and this is in reduced row echelon form. So that is that. I think we accidentally go through this. That was the question number 9 and 10 that we did earlier. So that's a check as well. Right. Next is in the linear system, vector or matrix form. So that will be 16 and 17. Right. So in the matrix form, this one, the first one is a vector equation. So just in the vector equation. So first we will look at the columns. 3 and 5. We have negative 5 and nothing here. Can also put 0, and then negative 1 and 3. So those are the 3 coefficients, if you will, and we're going to put that in the vector. And then on the other side we just have that vector. Right. Now the first one, we see the matrix, this value is multiplied by x1, so we just have x1, and the second is x2, and then x3 for the third row, and that's pretty much it. This is the equation in the vector equation, in the vector form. Or it is a linear combination of these three vectors. Right. We do not need to solve this equation, so I'm just going to leave it at that. So that is in the vector form, or the vector equation, or the linear combination of vectors. That's 16. I put on the wrong row, so it should be 16 and 17 here. Sorry. Right. This one we put in the matrix equation. So this is in the matrix form. So in that case, we're going to put on the matrix equation will be in terms of usually AX equal to B. The matrix A is the coefficient 5, 1, -6, 3, -5, and nothing here. And then next, the variables. We have x1, x2, x3, and then just equal to the constant. So in this form we will have A is the coefficient matrix, X is the variable. We have three variables here, therefore 3 rows, and B is the constant, and the constant on the other side. Right. So that is, we write a system equation in the vector form and the matrix form. We check off that list. Check off that item on the list. Right. While we're here, let me just also go to number 14 just quickly, and then what we're trying to do. So on this one, we're trying to see that so for x1 and x2 if possible. So we're going to write in this form. So x1 coefficient for +1, -2, plus x2 matrix on the vector equal to all we need to do is put this in the matrix, and then do the reduced row echelon form. And that's pretty much it. Then we solve the solution from there. Right. Next we go to vector operation. That is like number 13, usually straightforward. We just do it by hand. Right. I'll let you finish that problem. Right. Vector operation. So all we need to do is 2 times this vector, and then add the other vectors. So 2 times 5 will be 10, -12, and then when we add them, that will be 8, -15, and that's that. Right. Next we write the solution of AX equal to B in a parametric form. then it can represent a line or a plane or just a point. Right. So for that we will have 18 and 19. Right. So for that one we also need to just put that in the augmented matrix, even though it's just one row. We can just pretty much do this by hand, but let's just use the calculator here. Right. Calculator, turn it back on. Right. Second matrix. I passed it. And then alpha, zoom, that get back to the matrix. This one only has one row. Oops. It enter one row, 4 columns, so that's still good. Okay. We pretty much divide everything by -2 and we're done for that one pretty much. Alright. Note that we still have x1 for first column, x2 second, and x3 third. And the pivot is on x1. X2 and x3, because of that, will be free. So I will write x2, x3 are free. From this equation, we will rewrite the row x1 plus 7x2 minus x4 x3 4x3 equal to 0, and if we solve for it, x1 is equal to -7x2 plus 4x3. Right, now let's just write that again in this form. x1 is equal to this. I'm going to stack a little bit different. I'm going to just write like this. You'll see why in a minute. And then x2 is free, so we just say x2 is just x2. X3 is free, so we just have x3. Now we're going to put this in a columns for vectors. Noting here we have -7, here we have 1, and here we have 0. So if we want to put that, it's going to be in this form: -7, 1, and 0. That are the coefficient of x2. Next, coefficient of x3, we have 4, noting here, and 1. So going to be 4, 0, and 1, and there's x3 here. So the solution in the vector form is going to be like this. And since this one has 2 parameters, so this represents a plane. 2 parameters, 2-dimensional object. It is a plane. Right. Next, this one. So we put in augmented matrix and reduce row echelon form. right? Second matrix, reduced row echelon form, alpha, zoom. This time we have 3 rows again. Right, values 2, negative. See, we cannot hit enter in this case, so to do over again, I just go back here, hit enter. Right, 2 is good. 2, negative 5, 3, negative 1, right, check the numbers. Right, and we have that. There's a decimal here, so I will change to fraction. Math, enter twice. Right. Right, a pivot here, a pivot here. X1, X2, X3. X3 doesn't have the pivot entry, so X3 is free. Right. So from this equation, we have X1 minus 7/2, X3 equal to 12. So for X1, that one, X2 minus 2, X3 equal to 5. So X2 is equal to 2X3 plus 5. If we put this in column, X1, X2, X3, X1 is 7/2, X3 plus 12. X3 plus 12 plus 5 for X2, and X3 of course is free, so just 1, X3 equal to X3. Now we put all the coefficients for X3 in the vector form of 7/2, 2, and 1. That's the coefficient of X3, and then we have the constant. Put 0 there, and this is the solution in the vector form. As we see, it has one parameter, so the solution represents a line. Right, so we have that. Next, it is linear independence. So pretty straightforward. There are 3 columns, so we're going to put that in the vectors. Put vectors in the matrix. Sorry, that's what I mean. Put the vectors in the matrix. And then do the reduced row echelon form. As you see, we do a lot of that on the first chapter. Before we hit enter, just need to know what we are looking for. So linearly independent, it is linearly independent if there is no free variable in the reduced row echelon form. So we just look for that. So hit enter, and that's what we have. This is one, sorry. So again, this one has a pivot on the first column, second column, and third, and there's no free variable. So this one is linear independent. Right. I need to change the red. Right. So linearly independent is where we have no free variable. By that we mean all the columns have a pivot. Sorry, just need to refill the red ink pen. Right, we're good. So whether we have a matrix or not, the matrix of the columns or just the vectors we stack in the column, we just find the reduced row echelon form if we have no free variables in the reduced row echelon form matrix. It will be it will be linear independent. Right. Next is linear transformation. So that linear transformation, is the good thing is that if it is in the matrix form like this, all we do is just multiply the matrix. So we have the transformation of the vector x is just a times x. So now transformation of vector u, it's just a times u, where a is this matrix, and multiplied by the vector u. Just need to multiply this. So the matrix here is 2 by 3. So alpha, zoom, 2 row, 3 columns. Right. -1, 8, -1, 3, 4, 2. Right. And then times. Just hit alpha, zoom, will be 3 rows, but just 1 column. Okay, that will be 8, 2, -3, 11 and 26. Should be simple enough. Need to update the list. Sorry. The linear transformation, we're going to have 21 and 22. Right. So again, this is a linear transformation given the matrix for the transformation. So the transform of the vector x is a times x. Now we just need to find the vector x where transforms equal to b. So we just write dx transform of vector x is equal to a times x. A is this. We do not know what x is, so just going to put that some matrix there, and this equal to the matrix B, because it said the image is B, so that will equal to B. Now we can check the dimension quickly. This is 3 rows, 3 columns. Sorry. 3 rows, 1 column. So in order to get this, the middle number must match. So the dimension of this matrix have to be 3 times something, and when the middle number match, the outside number will be the dimension here, so it has to be 1. So we will have x1, x2, x3. And now to test the system of equation, this should be simple. All we need to do is just put in the matrix form, or matrix that is. And we did many of this already. Just reduce row echelon form, and we have the solution. So that's pretty much it. Now we will find the matrix for the row operation. There will be a lot. Will be 23 to 25. Should we see that? There are a lot of things about transformation. The only thing we need to know is that whenever we're trying to find a transformation, we just need to know what happened. What will be the transformation of the columns in the identity matrix. So I'm looking for number 23 here. If we ask for the transformation, all we need to do is that. So we'll apply the transformation to the first column here of the identity matrix, the second and the third. So apply to the first column is 6 and -3. Second columns is that, and the third column is that. So the matrix for the operation is just going to be 6, -3, 2, 0, and -2, and 1. So that's pretty much the matrix. But look like this problem doesn't not only ask for the matrix, it asks for the transformation. So we have that applied to the matrix X is going to be equal to A, which is this one, times X. Now, the matrix A is this. The matrix X, right? Again, we can check the dimension. We have to multiply that something. But what's that equal to though? Notice that this is R3 to R2, so the end result, this should be a 2 by 1 matrix, because whatever the end is going to be 2 by 1. So this one is a 3 by 2 row, 3 column. So the middle numbers again has to match. So this has to be 3. And when the middle number match, the outside number has to be the same. So will have to be a 3 by 1 for the X matrix. So that 3 and 3 the same. 2 times 2 and 1 on the outside will be the dimension of the end result. The reason this is 2 by 1 because it is R3 to R2. So we know that it has to be 2 and 3 here. Right. Anyway, so that will be x1 and x2. Right. If we multiply it, it will be 6x1. Sorry, there are 3 of them. 6x1, 2x2 minus 2x3, and then the second row negative 3x1, 0x2, and x3. So we just multiply the matrices, and that will be just that. Right. Next, on this one, we asked to find the matrix of the transformation. Again, this will go from R2 to R2. Note in the R2, in the first one here, we did like the last problem, we try to find the identity matrix in R2, which will be this. We have 1 on the diagonals and diagonal 0 everywhere else. All we need to do is just find out what will happen to the first column and what will happen to the second column. Right. So ask what happened to 1 and 0 and what will happen to 0 and 1. Right. Now this requires a little geometry or trigonometry. Right. First, by the way, this is like x and y. So x is 1, y is 0. We have this point. Now, this will rotate 7 over 4 pi. So look like that's going to be almost 2 pi. So it will end up. I might just draw a circle first. This point is on the unit circle, and 7 over 4 pi is going to be here. So this point will go here. The coordinate of this point will be positive. X is negative square root 2 over 2, and y is x is positive, y is negative. Right. So the transformation of this is going to be equal to, we write that in the column x and y. Right. So the transformation of 1 and 0 becomes this. Next, if we have this point, which is 0 and 1, we'll rotate 7 pi over 3, 7 pi over 4, so we'll arrive to this point. The coordinate of that is just square root 2 over 2 and square root 2 over 2. So pretty much just that. And then the coordinate will be square root 2 over 2, square root 2 over 2. Now the matrix, we just put those columns together and we form the matrix. For that, simple enough. The matrix A should be square root 2 over 2, negative square root 2 over 2, square root of 2 over 2, square root 2 over 2. So we just see where the transformation applied to the columns of the identity matrix, and then we just stack the result and we have the matrix. Right. Same thing. Next one, in R2 the identity matrix will be the same, so we will going to have this matrix, and this we can write is E1, this will be E2. Right. Now we write, we know that the transformation we transform, we write like this. The first one point is the first E1 will go from 1 0. This will transform into E1 plus 5E2. It maps E1 to E1 plus 5E2. E1 is 1 0. E2 is 5 times 0 and 1. So it will be 1 on the top, 5 at the bottom. Right. And that will leave E2 unchanged. Right, so that's the first one. Then reflect the result to x1 axis. So let's see if we have the point here, x1, x2 reflects around the x1 axis down here. So x1 will stay the same, but x2 will change the sign to negative. So what we do is going to change this, reflect. X1 will stay the same, so we still 1 and 5, but x2 will change the sign. This is a reflect here. Zero and negative 1, and put the result in the matrix. Stack in the columns, first column, second column, and that is the matrix for the right. Except I forgot one thing. So then reflect. When reflects, actually this one we have a negative here. I forgot that. Sorry. Yeah, we only change the second component. Only change x2. So that changed second 2, and that changed here. Right. So that's what we have. So pretty much we just applied to the E1 and E2. Whenever it applies to the columns of the identity matrix, at the end we stack the result, and we have the matrix of the operation. Right. The last one is the onto and one-to-one mapping. I'll just keep this in mind though. We have two concepts. Need to know this. First of all, this is onto, and second one is one-to-one. So onto is equivalent to, let's say, it would be span. The same idea as span, and span is where we have we should say the pivot on every row. One-to-one, it is the same concept as the linear independent. And linearly independent is the same as no free variable, or we say the pivot on every column or no free variable. Right. So we have the matrix A here. Let's do the reduced row echelon of A. Right, and we have this. First we see that these are the pivot, and the first thing we see, the first row has the pivot, the second row has the pivot, the third row has the pivot. So pivot on every row. Pivot on every row. So that will mean it will span R3, or it's going to be an onto graph. And there's no free variable. So linearly independent, and this is also one-to-one. Right, so we just like that. This concept is a little more important. It's important, so we need to do one more example. Let's say, still that. Let's say we have a matrix of the transformation right, and then the question the same: is the linear transformation represented by this matrix is one-to-one or onto? Right. So what we need to do is just do the reduced row echelon form of A. Sorry, 3 bytes. This one has 3 rows and 2 columns. Right. Of course, we see there's a problem here. So to change that is the way to fix that. We still use a calculator though. Don't worry. Sorry. But to fix this, we have to add one more column. I'm glad at this. Right. And we just ignore the last column because 0 and doesn't matter what, doesn't matter the operation, the 0 here will remain 0. So we just put it there so it will define on the calculator. But when we write the answer, we just ignore it. That's what we have here. So what we see here is the pivot here, the pivot here. So we check. The first row has the pivot, the second row has the pivot, the third row is not. So we don't have the pivot on every row. So it is not span and it's not on 2. So we say no pivot on row 3. So this is not span and this is not on 2. Next, we check for linearly independent or the free variable. There's no free variable, so it is linearly independent, and this is 1-to-1. So this one we say no free variable. So linearly independent, and it will be 1-to-1. Right. So and with that we cover every topics for the test 1. I hope you find this helpful, and thank you for watching.